All right, guys, welcome back. We are now going to go over how to do another chi-square goodness of fit test, or the GOF test, using question number 2, just being because with the null hypothesis and the alternative hypothesis, we now see in our steps that this is not going to be a historical distribution. This is now going to be considered uniform distribution. So let's go over how to do that. You'll see I have the same calculator screen as before. Again, we're just continuing on with the second one. So I'm going to go ahead and just quit my screen. Actually, let's just clear it. And let's see our problem. We've got local vending machine at our school is giving us some drinks. Purchasing agent thinks each type of drink is equally key. Favored among the students buying drinks from machines. Here's the recent purchases that we see. Test the hypothesis with a 0.05 significance level, or otherwise known as alpha, to determine if the purchasing agent is correct. So notice how it said the word equaling. That gives us the indication that this is going to be considered a uniform distribution. The other reason why is if you were to compare and see it compared to the other problem, we don't see any percentages given like we saw in example or question number 1. So because we don't see those percentages given, it is going to be uniformed. So if we take a look at the card, we are still on a GOF test, and we'll go through the null hypothesis, but a uniform distribution. In order to get those expected values, we're going to follow not these 2 steps here. We're going to go ahead and only follow one of the steps, and we'll go over how to do that momentarily, but it's uniformed. So we have our null and alternative. We're talking about drinks, so I consider that the drink data is our actual variable here, and it follows a uniform distribution. Your alternative hypothesis will now say the drink data does not follow a uniform distribution. Again, like we know in our recipe card, which you hopefully have in front of you, is going to be your writing out of your equation. X squared equals observed minus expected squared divided by E. Now notice in step 3 it says to calculate the expected values. To calculate the expected values, and I'll go to the card, we're going to take the sum of the number of observations in the sample. Okay, the sum. So in this case, we are adding together 159, 198, 174, and 149. That gives us a total of 680. Notice I've written expected equals 680 divided by, and that's the second step. There is a note here, uniform distribution. Divide the sum of the sample observations by the number of categories. In our case, we are going to divide that by the number of flavors that we have. Well, we have grape, tropical, kiwi, and lemon lime. That's 4 flavors. 680 divided by 4 means we now expect 170 of them to be sold of each flavor. You now see I've listed out expected 170, 170, 170, 170. That then takes us to step number 4, which is to list out the expected values. I'm not going to waste your time. Write out just E equals 170, or just the number 170. You do not need to list this out 4 times because every single one of them is the same. Compared to in the last problem, you would list them out because each one is actually different. Step 5, enter in the data. Yes, we would just put a check once we get it into the calculator, but we do need to enter this in. So stat, I want to edit. I'm now going to go ahead and from editing, I'm going to put in the data we actually have. Now, let's say you don't want to sit here and delete everything. Remember, you can do a stat and you can clear the list and you're going to tell it what 2 columns. So 4, and now I'm going to hit second L1, comma, second L2 and hit enter. It tells me it's done. When I go into stat edit, you now see they've been cleared. So if you didn't know about that before, well, now you know. So let's enter in the data we have here in this case. So in case we're listing in L1 the observed. So I have 159, 198, 174, having a little issue, and I have 149. Next one, every single one of these is in fact going to say 170. So 170 is listed for my expected values in L2. So again, notice L1 is always observed. L2 is going to be your expected. But I will double check, like I always ask you to double check. My data is correct and matches exactly what I have. So we've entered the data. That is step number 5. And therefore, I now can press second quit. So I've gotten out. Now we're going to plug values into the actual equation. So remember, take your first set of values and your last set of values. 159 minus 170 squared divided by 170 plus plus 149 minus 170 squared divided by 170. We're now on to step number 7, which is to calculate the x squared and the p-value. So again, step number 7, we're going to do a stat test. Option D here. We're still doing goodness of fit because we're comparing one variable. So I'm going to do a stat. I'm going to go over to tests. Remember, you can use your up arrow. I want the GOF. I want L1, L2. I now need to do degrees of freedom. Remember, it's based on degrees of freedom is n minus 1. If we look at our notes, we had 4 flavors, but this needs to be your n value is 4. So I'm going to do n minus 1. So 4 minus 1. Again, type that in, let it do the math for you, continue on, and calculate. Now for our calculation piece, we get 8x squared, we're number 7 here, equals 8.01. I went ahead and rounded to 3 decimal places, so 8.012. My p-value, also 3 decimal places, 0.046, because the 7 would have rounded it to 6. Now that I've got my p-value, and notice that degrees of freedom is 3 there, but now that I've got my p-value, I've got to compare it to alpha. In this particular problem, it was 0.05, so there's 0.05. I have those 3 values, so 3 decimal places. Make sure we have 3 decimal places by adding on a 0. Now think of it again like money before deciding which way does that inequality go right here. $46 or $50? I want $50, even if it's just by $4. Therefore, because it is alpha, or the p-value is less than alpha, it is now a reject the null. So I'm going to reject the null, and now I'm on to my conclusion, which we know is filling in the blank. Now the last portion of this, again, talks about impacting your decision the most, CNTRB. Here again, CNTRB, it talks about contribution. So using my decimal, 0.7, I believe that was 0.7, going ahead using my cursor to the right, continues on, I now have 4.6. Keep moving on, I have 0.09, and then I have 2.5. Okay, it's okay that I did not round, because now from this list, from the CNTRB down here, I need to go ahead and pick which one is the greatest value overall. Greatest value is 4.6. That is the first, second. Look at our table. First, second. That means it is the kiwi strawberry drink was the one that contributed the most. We have the purchasing agent expected. Again, what did we expect? 170 to buy kiwi strawberry, but 198, there's our 198, is the observed, what we saw happen, actually bought it, and therefore kiwi strawberry contributed the most. Now notice this explanation is similar to the other one, I just phrased it a different way. I hope you find this helpful. Again, this explains examples 1 and 2 from your notes on chi-square goodness of fit, or chi-squared GOF, as I go ahead and call it sometimes. Hope you guys have a great day.